that AKG is 40 degrees. What do I already know here? If that's 40 degrees, what else is 40 degrees? Yeah, the arc AG is going to be 40 degrees. Focus. The arc AG is going to be 40 degrees. Okay, and then they tell us that KC is 9. Well, C is kind of up here, isn't it? What would KC be in the circle? Here's, it's a radius, so it's 9. So now I know what the radius is. Okay, so I've got some information here, and that's all they give me, and they want to know what is the length of arc AG.
They don't want the measure, they want the...
Yeah, just a second. Let me make sure. AG. Oh, AC is 40. No, AG is 40. Okay, so it is 40 degrees if they want degrees, but that's not what they're asking for here. So there's two ways to measure the arc. I can measure it with degrees, but what they want me here to do is to measure it like I had a tape measure or a piece of yarn measure it. And there's a formula for that. Isn't this AG, isn't it part of the whole circle? More specifically, it's part of the whole circumference, isn't it? If I want to know how much that little piece is, that's part of the whole circumference. So I'm not going to give you a formula for this. I'm going to tell you how to think it out, okay? And you'll get a formula at the end. But this is part of the whole distance around the circle, so it's part of the whole circumference. Well, what's the whole of a circle? Yeah, I'll get to that in a minute. Right now, the whole of the whole circle would be the circumference. I was looking for this hole here, but you're not thinking wrong because, yeah, that's that hole right there is 360 degrees. And so, like, what part do I have of that here? 40 degrees. I have 40 out of 360 degrees. So that's the part to hold. That's what you're going to do on these problems and on the other sheet too. Now, the distance around the circle is what Jessica said. It's the circumference, right? Mm-hmm. Do y'all remember the formula for that?
Isn't it like pi r squared?
That's area, and that's going to be the other sheet. We're going to do
diameter times pi?
It is diameter times pi, or 2 pi r. I'm going to use 2 pi r just because I like that better, because half the time you get the radius, and it's just easier to just plug it in. But you can use pi d if you want to. It doesn't really matter. You just need either pi d or 2 pi r. Either one's fine. So now, do I know the radius so I could plug it in? Yes, I do. What is it? 9. So I'm going to put 2 pi times 9 over here. I'm just plugging in the radius is 9. And that 40 over 360, if I can reduce it, I want to. And it does reduce. 40 goes into 40 once. How many times does it go into 360? 9 times. 9 times 4 is 36, so it's just 9. So, and then on the bottom, let's see. Oh, that's 9 right here. I didn't mean to put it right there. That should be 1 over 9 out front times 2 pi times 9. And can't I reduce a little bit more now? Doesn't that 9 could cancel out with that 9 because we're just multiplying it all together. So one of the reasons I didn't go ahead and multiply 2 times 9 and say 18 here was that I saw that if had I not marked it out, I would have had 2 times pi times 9 over 9 if I had, kind of put everything into one fraction, and then maybe it's easier to see that the 9s are canceling out. What's my answer going to be? 2 pi, and that is an exact answer, which is always preferred unless you're told to write it in round. Now, if I wanted to check it out, pi, they tell me to use 3.14 if I were given my answers the way they do in the bottom. So if you say 2 times 3.14, you do get 6.28 like they have it on number 1 there. See what they're talking about here. They tell us we're going to use angle 3, and if I look, you got like B here, and D's over here, and then you come down to N, and that angle right there is angle 3. Okay? They tell us that if that's 80 degrees, I'm going to label in a different color just so we can tell where the labels are. That's 80 degrees. Now here's something you don't know yet because it's on another video. It's hard to get all this in at once and find a set that just has certain types of problems on it. If you got a vertex on the circle like that, that's actually called an inscribed angle. because the whole angle is kind of inside the circle. You know, if you just cut it off where it hits the circle, it's called an inscribed angle. And an inscribed angle is always half of the arc it intercepts. So if angle 3 is here and it's 80 degrees, I know that the arc that cuts off is going to be double that, basically, because the angle's half of this piece of the circle, so that has to be 160 for half of it to be 80. I don't know why that was so hard for me to do these calculations when I was in high school. I just kept getting, is it half of this? What's half of what and what's double what, you know? But the angle is the smaller part and the arc is the bigger part, so it's half of the arc. Okay.
Is it always?
The angle's half the arc. Okay. So, let's see what else they tell us. BGN. Oh, guess what? Geez, here's K. Let me go back to black as I draw the circle. Here's K. And G is kind of like down here. Now, we know that BGN was 160 degrees, so I'm going to write that down because I'm probably going to use that in a minute. They want us to find BGN. Well, guess what? That's the part that we have the measure for, right? It is the red arc. I didn't have to trace over it again. I could have just said it's the red arc. So we know it's 160 degrees out of the whole circle. How would I make a fraction that says 160 degrees of the whole circle?
60.
Yeah, 160 over the whole circle, 360. So there's my part to whole. It always starts out being over 360. And I need a radius, and I bet they gave me one or some way to find it.
They gave us a diameter.
Okay, so let me go back to black and let's draw in. They're talking about AE here. A is here. E is over here. It's not really marked on your paper because it got chopped off because I made a poor, I copied it. So E's missing. It's basically if you go to A, go through the center K, and go to the other side, it's a diameter, okay? So you got a diameter there, and they're telling me that diameter, AE, is 14. So I'm going to write that's the diameter. So if you're using pi d, you'd have 14d there, but if you're using 2 pi r, like me, you would be plugging in 7 here, wouldn't you? Because I'm using the radius, so I need to half it. That's why it doesn't matter. You can use whatever formula you want to.
Would it also work with 80 over 360?
Okay, so now all we got to do is just do some reducing here. I'm going to cut the zeros off the 160 and the 360, and I then go, oh, it's easy to reduce this because 4 goes into 16 4 times, and 4 goes into 36 9 times, right? On the top, I have a 4, a 2, a pi, and a 7, and on the bottom, I have a 9. Is there anything else I could reduce out of that before I go put it together? None of those things divide into 9, do they? And again, you could do this part with the calculator. Just leave the pi out, and you could use your calculator and just multiply straight across the top, divide by the bottom, just leave pi out of it, and write pi down. Kind of treat pi like an x here. Isn't that kind of what we're doing? We're keeping it with it like it were an x or something. So if I multiply across, I have 4 times 2 is 8, times 7 is 56 pi on top, and then, you know, I could put these over 1 and say 9 times 1 is 9. But that would be my answer, and if you divided it out, you get what they have on the bottom there. So on the second worksheet, which is actually, it says Activity 3. Oh, it timed out. On this one, if you look at this sheet, they're talking about the area of a sector, and a sector is like a slice of pizza again. So if I have a circle, and I have cut a piece out of it, or I'm looking at a certain piece of it, wouldn't that be part of the whole area of the circle? If I want to know the area of that piece, it's part of the whole area of the circle. So guess what we're going to do here? We're going to do part of the whole, and then we're going to, so I'm going to write that down first, and then I want part of the whole area, so I'm going to do the area of a circle, and Elena said it's pi r squared, right? There's not 2 formulas for this one, really. So the area of a circle is equal to the part that you're out of the whole circle times the area of the circle. You can get formulas for these, and they look really confusing, but if you kind of understand what's going on, you won't ever have to try to memorize the formula other than if you don't know the area of a circle or if you don't know the circumference formula. Okay, so that's all I got to do here, and I say that, and then these problems get kind of difficult because they made them difficult. All right, let's just start with number 1. So you have your circle. This circle is circle M. And one of the things they're going to play off of in this whole thing is, if I go up here to B, let's see, that would be a radius, right? I've got another radius here that's G. And they have divided this into like 3 angles or 2 triangles and an angle. I don't know how you want to look at it. But here, let's see. Oh, there's a chord here. This gets really complicated. There's a chord here, AC, and they make it a perpendicular chord. So this is going to help us get some right angles here in a minute, and we're going to have some right triangles. So if I come in here, this is a right angle here, and they call this angle 2, and then they call this angle 3, and then angle 4 comes down here, and what they're going to do is kind of take turns making that a 45-degree angle sometimes it's going to be a 60-degree angle. So we're going to have to go back to our special triangles, 45, 45, 90s, 30, 60, 90s, and that kind of makes this a little more difficult. Okay, so they tell me that the measure of angle 2 is 45 degrees. I can't write really on that without it being so awful you can't read it. And they tell me that MP is 6 centimeters. What? I mean, you look at that and you think, why did they tell me MP? Well, let's see. There's a point here, P, and it goes up to G, and it's a right angle. And they're telling me that this piece, MP, is 6 here. Am I right? Yeah. So what I have to do is kind of come off to the side. Actually, I do need to know that measure of angle 2 is 45 degrees, and here's why. Triangle 2, the triangle that has 1 and 2 in it, if you look at your paper, it's congruent to the one that has 4 in it. If you look at those are congruent. They both have radii as their hypotenuse, and how did I figure out that it was here? Let me think. They want me to find the arc AMB, or sector, the area of sector AMB. So AMB means they want this right here. I'll just kind of mark it with red slashes in case I need to look there. What kind of angle is angle 2? Huh? Well, it is. It's a minor arc, but at angle 2, isn't it a central angle? And they told me it was 45 degrees, so guess how much is AB going to be then, here, this little arc? It's going to be 45 degrees because it's a central angle, so it matches. So if I want my part of the whole for this sector that I colored in, and I'll finish it right now just so you see I'm talking about this, I'm going to use that concept or formula, whatever you want to call it. Some people would say it's not a formula yet, but the part, I've got 45 degrees out of the whole 360 degrees, right? And then it's pi and the radius squared, and they didn't tell me the radius. Since the triangles are congruent, if I kind of come down here, I know that this is a right angle. I know that 4 is 45 degrees because 2 is 45 degrees. So I have a 45, 45, 90. So let me label it first. Across from 45, we call that X. Across from the other 45, we call it X. And then the hypotenuse is X squared to 2, Drew. And so now they told me that this piece MP, which is right here, they told me it's 6. So isn't MG a radius of the circle, right? I can figure out from this triangle that MG, a radius of the circle, is actually 6 squared root of 2 because it's X squared root of 2. So this would be 6 squared root of 2, and that's what I need to plug in. I need 6 squared root of 2 here, and I just simplify.